So what we're here today to talk to you about is how we're working to transform Dow Jones into a data business. So the data engineering team, which Dylan was manager of, we had the opportunity to move an over 30-year archive of premium news data to the cloud. And by experimentation with cloud-based services, we were able to identify usage patterns and optimize our architecture in order to meet those usage patterns. So what we're going to talk to you today is how we were able to learn through experimentation, how we were able to identify opportunities to either optimize for cost or optimize for customer performance, and how those lessons learned have influenced how we're transforming our business and future-proofing in future data-driven developments. Go on to the next. Okay. Dow Jones had an over 30-year archive of premium news data that existed only in on-premise infrastructure. What we discovered is that it met the need of our existing use cases, which were predominantly around advanced research and advanced analytics, predominantly focused at research librarians. But we were getting increasingly frequent requests for extractions of data. And that was actually really challenging in our on-premise infrastructure. So what the data engineering team was charged with doing was actually doing the migration to the cloud to support existing use cases for the advanced research, new use cases for machine learning and big data workflows, as well as being innovative enough to be future-proofing for whatever is next. So Dylan, what were some of the original challenges in making this data available to customers?
Oh, so for this new class of customers, these data scientists, they required more data. So we were trying to fulfill their requests, but they needed more data than we needed for the researchers. So with this on-prem database, we'd have to give them the data on weekends or over the low traffic times that we had for our research product. But that just wasn't working. We weren't able to fulfill the requests of our customers that were needing this data. As a result, we were actually posed the question, are we going to stay on-prem and try to scale up, or are we going to move to the cloud where we can massively scale up ephemerally, with ephemeral clouds? So due to this lack of bandwidth and this lack of scale and the size of our team, we decided to move to the cloud, specifically the Google Cloud, because they gave us zero ops options. I have some listed here, like Dataflow, Dataproc, and also GCS. I'll go over those when we go over the architecture later. So yeah, I'm just going to hit home again what the pros and cons are for moving to the cloud. You can scale massively, especially for these data science workloads where you're going to need large clusters to process all this data. For us, it's over 30 years of news content from over 33,000 news sources. It also allows for smaller teams because you have these managed services that you can take advantage of. It also allows to give you disaster recovery capabilities that previously were not available because on-prem, we only had a limited number of locations. With GCP or with cloud offerings that we have available to us now, we can be located in different countries throughout the world. And given this upfront cost, we still wanted to move forward to the cloud. So I'll bring it over to Patricia to continue us on our journey. Well, after I step us through the architecture here. So here's our simplified architecture. What we had was a news content feed on the right side there. That's kind of shown as a Mario warp pipe. And that fed into GCP or GCS for storage. And every day we'd have a Dataflow job that would process all those news events. There were updates, deletes, or additions of articles. And that would be pushed into data store. From there, our customers interact via an API. But this API, we had to apply custom DSLs. So that was problematic, along with the fact that it was pretty expensive off the cuff here. And I'll let Patricia let us continue on.
So once the 30-year archive was moved to the cloud, what we wanted to enable was really this, the opportunity to integrate our data with machine learning workflows as well as big data workflows. So we discovered that we identified two delivery mechanisms that we wanted to enable via cloud services. First delivery mechanism was what's called a snapshot, and that's a downloadable extraction of data, a custom data set for whatever is the specific use case, that can be either transferred to a cloud provider to work in existing workflows, or can be downloaded to any enterprise customers on-premise behind a firewall. So if privacy is an issue, we're able to meet that need. The second delivery mechanism we enabled was what's called a stream, and that's a custom filter of incoming news, near real-time ingestion that can either be used to keep a data store up to date, or it can be used for things like risk target identification, brand management at scale, due diligence at scale. So these are the delivery mechanisms we wanted to investigate and make available via the DNA platform. What we discovered early on in our initial experimentation with cloud architecture is that the usage pattern, moving to the cloud gives us a better opportunity to track and identify and understand our usage patterns, and our architecture needs to be adjusted to meet the needs of our usage patterns. And we identified kind of trade-off decisions that were either to optimize cost or to optimize the performance for our customer. One opportunity, so what we're going to do today is we're going to use this balance as an analogy for what is either the optimization of cost that's enabled via cloud services, or the opportunity to improve your performance to your customers by leveraging cloud services. Cost optimizations, if we were going to improve our cost, for example, in the use case of a snapshot, which is a downloadable extraction, what we identified is the usage pattern is very consistent. So these are workloads that can be done in batch processing. These are workloads that can withstand interruption. So what we have is we could make an investment in cost optimization by using preemptible instances. We could invest in cost optimization by investing in tiered storage, by leveraging the advantages of tiered storage. You could do this the same with sustained use discounts. And you'll notice as we leverage the cost optimization, the performance may go up, and the performance may degrade. So as you're optimizing either for cost or performance, the key is not necessarily finding equilibrium. It's striking the right balance of cost to performance for that specific use case. Now, streams, on the other hand, which is a near real-time filter of data, well, that we would really heavily weight being highly available and being reliable. In that event, we'd really want to invest in managed services, and we'd want to invest in read-write access, and we'd also want to invest in analytics capabilities. So in investing in our performance, the performance time goes down, but the cost may go up. So it's really, as I mentioned, never a matter of trying to strike equilibrium. It's a matter of trying to find the balance that meets your specific use case. So Dylan, once the data was made available in the cloud, can you walk us through some of the cost to performance trade-offs that you discovered with Data Store?
Yeah, so with Data Store, we were giving high availability reads and writes, and also it integrates really well with our pipelining tool, Dataflow. It also allows us to scale a lot better than we did on-prem. Some of the cons were it's very expensive for the read and write operations, especially for the usage patterns we were seeing. On top of that, we had to create our own DSL and educate our customers on that DSL. So there was a better way for us to move forward. And Patricia?
Yeah. So for the product of snapshots, we do require analytics capabilities, but we also require the read-write capabilities. Data Store proved to be a little bit, to really meet the need for analytics for the performance expectation of our customers, but did not meet the cost performance needs. So Dylan, what were some of the advantages in moving towards BigQuery as our search index?
Yeah, so I'll explain the architecture and then kind of bring to light the optimizations we made that made this a better architecture than the one that we had for Data Store. And I'm going to explain it from right to left, starting with the Mario pipeline of content. And so yeah, that's still feeding into GCS with those events that we're using to update our archive. And then we still have that Dataflow pipeline that updates daily, except the difference here is we separated our query layer from our storage layer. And for our query layer, we use BigQuery, and BigQuery allows us to have that SQL, the standard SQL syntax that we can use and allow our customers to leverage as well. And also we have GCS to store our full set of content. Another reason we had to split our query layer and our storage layer was because there were some limitations with BigQuery, specifically the extraction limits that we ran into. We do not run into this with the current architecture, and I'll kind of bring that to light through the customer's journey when they submit a request for a snapshot. And that can be seen here on the right side. Our customers interact with the APIs. And what they're requesting is a snapshot of data. And once they submit that request, an example request would be for all English content that we have in our archive. And that'll kick off a data flow snapshot or a data flow job. And what that data flow job will do is it'll go to BigQuery with that where clause and grab all the IDs of the articles, the identifiers for the most current version of each article. And from that point, it'll do a co-group by key or just a sort of join with the data we have stored on GCS. From that point, once it has all the content identified, it'll then output the snapshot to a location that the customer can use to download it. But that's still done via our APIs, and our customer still has no idea that we're no longer using data store. So that's the architecture, and I'll kind of reiterate the pros and cons of this. So with these resources that we're spinning up with Dataflow, they're ephemeral. So we're not incurring that cost as time goes on. We're only incurring the cost while we're doing the operation. We're doing the snapshot, for example. We're not paying a high price for updates to the archive as we were before with Data Store. Also, we get that free query syntax that BigQuery gives us with SQL. And GCS is very cheap. So it's the perfect place to store our data when we're not using it. So with this architecture, we still have that very expensive joining process with the query layer and the storage layer. And we also need a separate cluster for each and every operation. So there may be a better way, and you may see that further on in our talk here.
So in moving to using BigQuery for our analytics, we were able to do big workflows at a relatively inexpensive. BigQuery is relatively inexpensive for analytics capabilities, but we hit some quotas and we hit some limits when it came to extraction, which is why we then paired with Google Cloud Storage. We really use the cost optimizations of the tiered storage with the analytics capabilities of BigQuery. So Dylan, in our snapshots architecture, why was the move made from Dataflow to Dataproc?
OK, yeah, I'll explain this architecture, and you may see the cons kind of bubble up, or what no longer are cons with this architecture. So here we still have that Mario pipeline of content going into GCS, updating daily, and going into the content archive we have here. That's a little different, as you may see. The customer is still submitting API requests, but when the customer submits an API request for all English content this time, they're just going to be having a job spin up, and we can use Dataproc and their SQL syntax to create this snapshot of content that'll be delivered to our customer. There were some cons with this method, but I'll go over those after I go over the pros, because this is a good thing. So with this architecture, we were able to share resources. So when we had two customers make a snapshot request, we can still use that same archive of content. With Dataflow, we'd have to load it into our cluster each and every time. Here we can we can mount the same drive and the same content. So this also more closely aligns with our usage patterns. We have more and more customers join and use our platform. And because of that, we can use these higher cost resources when it comes to doing the operations. There's also no need for that joining of the query layer and the storage layer, because we're using Spark on Dataproc, which has a SQL syntax that we can leverage. But with this, there is still more operational overhead. With Dataflow, it can recover from errors or any issue with the cluster. With Dataproc, we still have to kind of build in some logic to kind of restart the cluster and recover from errors. On top of that, when we moved from BigQuery and went to the Spark syntax, we had to create some UDFs to kind of bridge that gap between functionality. And yeah, for those of you interested, it was related to regular expressions. And I'll throw it over to Patricia to continue us on this journey.
So we have a relatively small team. We started with 2 engineers, and we now have 5 engineers. Through the experimentation in moving to the cloud, we were able to identify that the usage pattern for snapshots is very consistent and it's very predictable. So it was a worthwhile trade-off to go to the increased overhead of an unmanaged service, as it gave us increasing control over the expensive operations like joining and windowing. So there was a cost benefit to us that was worth it and worth taking on the overhead. So Dylan, what were some of the, for streams, which is a near real-time filtered stream of data, where highly available service is weighted heavier, why was the choice made to move from Dataflow to Dataproc? Or Dataproc to Dataflow?
Yeah, we're going back
We've
and forth.
had that same conversation 1,000 times.
Okay, yeah, with the streams architecture, our customers are going to notice if it goes down for a few minutes or seconds. Unlike with snapshots, they're not going to notice because those operations are going to take between an hour or 2 hours. It's low latency, so they're going to notice when messages are not streaming to them. With this, we're still hooking into that stream of content that's coming from the Mario tube, but it's streaming onto PubSub right now. And we're still leveraging the Dataflow services to do our ETL processes. And the great thing about Dataflow is you can write job for a batch or streaming job, and it's going to be either the same or similar. So we're taking advantage of some of the code we wrote for snapshots and using it in streams to filter and update our content. From that point, we stream it out to we filter it into different product types because we have content that's licensed to only certain products. And we use Dataflow to filter that content. From there, this is where our customers kind of interact with our system. They use our user APIs as if they would be using a snapshot. They submit the same query. Like if they want all English content, they'll submit that little where clause. And from that point, we'll spin up a Dataflow filter. Before, though, that was a Dataproc filter, and I'll go into the pros and cons as to why we changed that part of the architecture. So now, once the customer has created the stream and they have their custom set of content streaming to them on this PubSub topic here, they can then use our client code and get streamed all the content that gets filtered down to them. But we had to make that move that I was talking earlier from Dataproc to Dataflow, and that was because every time we would use preemptables in our cluster, it would take down our stream, and our customers would notice. With Dataflow, we actually have had streams that have been running for multiple years. Along with that, it allows for this fully managed zero-ops data processing, and for our small team, this is great because we don't have to wake up in the middle of the night and handle an issue. It also allows for more seamless auto-scaling, which helps with smaller teams, and with streams, there was not a heavy load as we only receive like 800,000 messages a day. And in big data land, that's not a lot. So yeah, there were the cons of not being able to use preemptables, which were very cheap. If you do use Dataproc, I suggest looking into it. And also, we had to kind of leverage an in-memory database for the queries. We didn't have the BigQuery syntax or the Spark syntax that we could plug into and use SQL. But if I were to do this again, Dataflow now has a SQL DSL, which we have not used. I'll throw it over to you, Patricia.
Thanks. So sort of to summarize some of the lessons learned, the usage patterns seem obvious, but actually once we released it to the world, we did have some APIs that were used in ways we hadn't intended. And all of a sudden, your costs skyrocket, and you start becoming very painfully aware of where you have opportunity to optimize and where you have opportunity to change. So what I would recommend and advise is initially, we were sort of always optimizing for performant responses. And if you invest too heavily in one side of the trade-offs, you fall over on top of yourself. If you're only investing in one side, you get skewed off balance really quickly, and that becomes very apparent when you get the bill for the service. We had a use case that ended up being like a $70,000 use case that we were not expecting. So what we really learned is in any time we do a feature development to first identify the usage pattern, identify the behavior, really understand from your users how they're intending to use it, which might be different than your original assumption. And then once you do understand the usage pattern, to build in such a flexible way that you can understand the trade-off decisions you're made versus the performant experience for your customer and your opportunities that the cloud enables you for cost optimizations. So Dylan, what were some of the lessons you learned in making this new product available on Google Cloud?
Okay, yeah. One thing that we found useful as we're developing this new product that we've not built before was we built time in our roadmap to iterate and spike on new infrastructure when we could. Google's always developing new like zero-ops tools that you can use, and other cloud providers are as well. We actually started on a different cloud provider before we moved to Google. Also, we learned that being an early adopter is a double-edged sword. You can guide the roadmap for their products, but at the same time, you can use one of their products and it can tip over in a way you would not previously have expected. Also, Google very tightly, they keep their quotas down to a limit that prevent you from incurring a lot of costs, but at the same time, it could cause an issue in the future. So it's good to know your quotas, especially when you're an early adopter. This can actually be boiled down to 3 things when you're deciding on our architecture. The first one is cost. The larger you can make that margin for costs of operations, the quicker you can grow your team and iterate on features. Another one is team size. There are some architectures that may not work for your small teams, especially if you want to have a team that can develop features, and you don't want to be spending half of that time managing infrastructure. This is why Google Dataflow and Dataproc have actually come in handy for us and kind of accelerated our roadmap. Another one is, we kind of learned trial by fire, is usage patterns. We had a new product with a new use case, and our customers were using it in a way we did not expect them to use it. As a result, we took advantage of the fact that we had time in a roadmap from using these zero operational tools, and also the fact that we built into a roadmap this time for iterating on our architecture. Luckily we were able to adapt and change according to these usage patterns, but it's very important to keep a very tight eye on that, and maybe even log that data somewhere so you can be alerted of when like your costs are kind of spiking and it's time to address that issue. So those are the lessons I learned.
Yeah. So in making this new product available on the cloud, we meet our existing use cases of advanced research. We've also now made a new line of business for machine learning and big data workflows. And Dylan can walk us through some of what we've also enabled in terms of applying these lessons to even future-proofing and some kind of new and upcoming things we've got going on.
Yeah, so this was just about news content, but with news content, you have different entities. You have organizations, you have people, you have events, you have like different industries affecting the news. So there's a lot of context that can be gleaned from different sets of data, and DNA has allowed us to kind of build on the top of the shoulders of this platform and create products that can generate knowledge. And actually, you can get signal from these news events. And we're doing that by structuring a sort of knowledge graph in the way that Google's doing for their search engine. We're going to be doing for the news and events. So we've been able to work on that, develop new context, traverse relations through our graph architecture. And on top of that, if you're interested in the kind of content we've been dealing with here, we have a commercial data set in BigQuery. Just Google BigQuery commercial data sets DNA, and you can take a look at the kind of news content we've been dealing with. That's
so the knowledge graph is kind of the next big thing we've got coming up, and we're so excited to have this premium news content, but also available with the entities that exist, the relationships between those entities, so you have the data in the context of the data, which is something we're really excited about.